So hello and welcome to CS Cult, and in today's video we're going to discuss about the medium problem of bit manipulation of module 1, and the problem is check whether kth bit is set or not, right? And the problem statement is as follows: we are given a number n and a bit number k, and check if the kth bit of n is set or not, and a bit is called set if it is 1, and position of set bit should be indexed starting with 0 from LSB side in the binary representation of the number, right? So if we have n equals to 4, then and we have k equals 0, so the binary representation of 4 is 1 0 0, and the 0th bit from LSB is not set, so we are going to return false, right? This is not set, we are going to return false. And what if we have n equals to 4 and k equals to 2? So this is 0 1 and 2, so the second bit is set bit, so we are going to return true for this test case, right? And what if we have n equals to 500 and k equals to 3? So the binary of 500 is 1 1 1 1. Let's see the last third bit. We have 0 0 1 0, so this is the last 3 or 4 bits, so we have to check for the third bit, right? So which is 0 1 and 2 and 3. So the last third bit is not a set bit, so we're going to return 0, which is no, right? So this is our question. So for naive approach, what we can do is we can use the approach we discussed earlier. We are going to create an array of 32 length, and we are going to store the bits of the given number n in this array, and we're going to check if the bit at kth position is set or not. Let's see if we have. Now let's take an example, and let's say we have number n, and the binary of that number is 0 1 0 1 1 and 0, right? And this is position 0 1 2 3 4 and 5. What if we so let's say we have three questions. We have first we ask for the bit at third position, and in second one we are asked for the fifth bit, and in the third one we are asked for the first bit, right? So for third bit we're going to check for the index 3. So the bit at the third index is 1, so we're going to return true for this one, right? And for the bit at index 5 we're going to return we have 0, so we're going to return false for this test case or this example. And for the first bit we're going to return true, as it is a set bit, right? So this is our question. So this is how we're going to solve our question in ON. So this is a naive solution for our question. So now let's talk about the efficient solution to solve this question. And the idea behind the efficient solution is we will be using left shift operator, right? And we have to find if the kth bit of the number n is a set bit or not. We have two bitwise operator to solve this question. We have and we have or, right? So if we talk about OR, so OR will always give us 1 unless or both the bits are 0, right? So we can't use OR for this question, so we're going to use AND operator. So how are we going to use the AND operator? So for AND operator, it will give us 1 only if both the bits are 1, right? So we can use this to check if the kth bit is set or not, right? So let's take an example. If we have a number as 1 0 0 1, right? And if you want to find if the second bit, which is this one 0 1 and 2, if the second bit is set or not, so what we are going to do is we are going to take a number whose second bit is set bit, only the second bit is set bit and all the other bits are 0. So let's say we have this number as whose second bit is set bit and all the other bits as 0. Right, we are going to do AND operator of this, and if we get 0 as an answer, which we are going to get here, then the kth bit is not set, because if we get 0, that means all the bits are different in both the numbers, right? So the answer is false. We don't have these kth bit as set bit. Now let's take another example where this kth bit is a set bit. So let's have 1 1 0 1, right? And we have to see if the third bit is a set bit, which is here, right? So we'll have a number whose only third bit is a set. So we'll have 1 0 0 0, and we're going to do AND of this number, so we'll get 0 0 0 and 1. So this is not 0, which means the kth bit of the number n is a set bit. So our answer would be true. Yes, the kth bit is a set bit, right? So how, now the question is, how are we going to get this number? So this number is nothing but 1 left shift k times. So we have discussed the right shift operator in the previous question. Now let's see the left shift operator, right? So if we have like for this question, right, we have n k equals to 2. This is k, right? So we're going to shift 1 to the left 2 times. So let's do it step by step. So we have 1 left shift 1 time. So what we'll get is 0 0 0 1 left shift 1 time. So we'll get 0 0 1 0, right? And now we have to do it one more time. We will do 1 left shift 1, which is 0 1 0 0. So this is a number we are getting, right? And same for the for this, we have to do it 3 times, one more time. So right, we'll do it one more time, left shift 1, which is 1 0 0 0, and that's here, this number. So this is how we're going to get this number, and after that what we are going to do is we are going to AND this both number. So the formula which we are using is we are using n and 1 left shift k times. So this is our basic idea to solve this question efficiently, right? So let's take another example. Let's see if we have a 1 1 0 0 1, right? And we have to check if the 0 1 2 3 fourth bit, if the fourth bit is set or not. So what we are going to do is we are going to do 1 left shift 4 times. So this will give us 1 0 0 0 0, right? This will give us this number, and we are going to do AND of this number with our n, and we're going to get something like this, and this is not 0. That means our fourth bit of n is a set bit. So that's our answer, true, right? So this is the basic idea how we're going to do this question in efficient log n time. So now let's see the code for this question, right? So the code is here. We are going to use this is our class solution, and we are going to use bool check kth bit. In 10, n is a number and k is the bit. We have to check whether it is set or not. So what we are going to do is we are going to check if n and 1 left shift k is 1. If it is 1, if it is not 0, then we're going to return true, and else if it is, if this this thing gives us 0, then we're going to return false, which means the number we have does not have a set bit on the kth position. So this was the efficient approach to solve this question in log n time. This will take roughly log n time, right? So this was the efficient approach. Thank you.